Okay, we have some key ideas here. If we have a function of degree n, then the function has at most n minus 1 turning points or vertices. If c is a zero of odd multiplicity, then the graph crosses the x-axis at c. In other words, here's my x-axis, and if we have an odd multiplicity at this zero, the graph will cross through the x-axis at that point. If c is a zero of even multiplicity, showing up an even number of times, then when you're looking at the graph here at c, the graph will turn around and just be tangent to the x-axis at that point. Now that's an important feature. That's why we've been talking about this multiplicity all along. Now let's look at our first problem. They have given us the graph altogether. Determine the minimum degree based on the number of turning points. I see 1, 2, 3 turning points, which means, let me just write that down, 3 turning points. Therefore, the degree has to be at least one more than that. The minimum degree is 4. Does that guarantee that this is a 4th degree function? No. It could be a 6th degree or 8th degree, but we do know it's going to be even because both ends point in the same direction. Determine whether the leading coefficient is positive or negative based on the end behavior. Well, we know that it is an even function because both ends point in the same direction, and since both ends point up, that tells us we are going to have a positive leading coefficient. Now, we want to approximate the zeros and their multiplicities. Looking at the graph, we have 1, 2, 3 x-intercepts. The first two cross through the graph, but the second one is a turning point. So let's take a look here. The zeros, based on the graph, appear to be approximately at -4, -1, and 3. Because these first two crossed through the graph, they are going to show up an odd number of times, having an odd multiplicity. But 3 is going to have an even multiplicity because at 3, the graph turned around and just touched the x-axis there. Let's look at this next graph. We see that there are 1, 2 turning points. And therefore, the degree, or the minimum degree, has got to be 3. If the degree is 3, there's at most n minus 1 or 2 turning points. So going in the other direction, we can add 1. Now let's look at this. We've got the ends pointing in opposite directions. Okay, and since it's starting at the top left and ending up at the bottom right, we know that it's going to have a negative leading coefficient. So this is an odd degree to function, and we know that there will be a negative leading coefficient, just what I stated. Now let's look back at the graph again. We seem to have 1, 2, 3 x-intercepts at -4, -1, and 2, and it crosses through all 3 times. That tells us, here we go, our zeros are -4, -1, and 2, and all 3 of these have an odd multiplicity.